So now we'll move on to part 2, where we will create the database. Okay. So part 2 is easy. We have done very recently. So we'll create a database. So I'm creating the DB tier. See, first we need to create a subnet group. So we need to group the subnets where we are going to place the database. And for today's session, my aim is I want to create a MySQL DB instance in one availability zone, which is going to act as primary. And there will be a standby database in the second availability zone. So I want to group the subnets where the DB is going to get created. Right. So that is first step. Okay. So you need to create a DB subnet group before creating the database. Okay. So I'm going to create a subnet group with the name DB subnet group. So this time you need to go to RDS console, RDS MySQL. So I'll go to subnet group. Okay, here it is. Okay, I'll create a subnet group with the name DB subnet group. Okay, you can give a description. Select the VPC and select 1A and 1B availability zone. And when selecting the subnets, because we want the DB to be placed on the private DB subnet in AZ2 and in AZ1. Okay, select the private DB subnet AZ1 and private DB subnet AZ2 and click on create subnet group. Okay, so we have created a subnet group. Subnet group is group of subnet where we are going to place the database. Okay, so now I'll create the database. So I don't have a database in Mumbai region. So now I'm going to create a database instance. Okay, I'll go with MySQL. And I'll go with the name DB instance 3 tier. Okay. Right. So I'll click on create database. So I'll go with standard create. I'll go with MySQL. See, if you select free tier, it will be a single AZ DB instance. But if you need high availability, like this drawing for the database, you need to select dev test or maybe a production setup. Okay, I'll go with dev test. This will not come under free tier, but I'll go with dev test and I'll select multi-AZ DB instance deployment, okay, which you might have not done in the regular classes, but I'll go with multi-AZ DB instance deployment. Okay, so this will create one database in availability zone 1 and another database in availability zone 2. Even though it is creating two databases, okay, so traffic will never forward to the standby database. Okay, traffic will be forwarded to the primary database. In case of a disaster in availability zone 1, only then the standby will become primary and then the traffic will get automatically redirected. Okay, right, so I'll create multi-AZ DB instance. Okay, I'll go with the name DB instance 3 tier. You can go with any name. So username is admin and I'll set a password. Remember this username and password, we will be using it in the application code at later stage. Okay. And I'll go with very small capacity because I'm just doing training. We don't really need high capacity servers. I'll go with T3 micro. Okay. And we don't need high capacity storage. I'll go with GP2 and I'll go with just 20 GB storage. Okay. And this database is going to be created in the VPC which I created, and it is going to be placed in the DB subnet group which I created. And I don't need public access for the database. Database has to be in the private subnet. People in internet is not going to access the database. So it can be without public address. And now we need to map the security group. See, we created 5 security groups in the previous step. So we need to select the DB tier security group. This is for the database, right? That's it. So you don't need to make any changes. That's it. So I'll click on create database. Okay. See, like I told you, it will not come under free tier, but you are not going to be charged immediately $41. If you create this project, run for like around 3 hours, 5 hours, you'll be charged like less than $1, $2. Okay. Right. So I'll create it. Okay. So I gone with standard create. I gone with MySQL as the engine. I gone with dev test, multi-AZ DB instance for high availability. Gave a username and password. Gone with the smallest capacity, smallest storage. Selected security group. And that's it. I didn't make any other change. I'll click on create database. Okay. So this will take time. This will create the DB instance in the first availability zone and the standby instance in the second availability zone. Okay. Right. It will take time. We don't want to wait watching this console. So we'll move on to the next part. Okay. It will not show two instances. It will just show here somewhere multi-AZ as yes. Okay. It is a multi-AZ deployment. That's it. Okay. Okay. So we have completed part 2. So we created a subnet group and we deployed highly available DB instances, okay, across availability zone. Right. Okay, so any questions? Okay, so if not, I'll again move on. Okay, this time what we are going to do is part 3. So we are going to launch an instance. Okay. So I'm going to launch a EC2 instance here. Okay, this is going to be configured as app tier server, app tier instance. And I log into this instance. Okay, I don't have any public subnet instances, but there is a service called SSM. Okay, with that, I log into this EC2 instance. Okay. And from this instance, I'll connect to this DB. I'll create a database. I'll create some tables. I'll create some data within it. Okay, this is what I'm going to do. Okay, so first let's launch this EC2 instance. Okay, so I'll go to part 3 instance launching step. So launch a EC2 instance with the name app tier instance. You can go with any name, but I'll go with app tier instance. Okay, so I'll go to EC2. Okay, so I'll launch instance. I'll name it as app tier instance. I'll go with Amazon Linux 2023. I'll go with smallest capacity T2 micro. See, I don't need any key. Normally in our courses, we use key-based login, but there is a topic called SSM. We don't need a key. We are going to use a different method to log in today. Okay. Right. And I'll select the VPC. And I want this instance to be placed in the private app subnet AZ1. Okay. Private app subnet AZ1. Okay. So according to the drawing here, private app subnet AZ1. Yeah. Okay. And I don't need public access because it is a private subnet. And I'll map a security group. So I'll map the app tier security group. That's for that only we created this security group. And at the time of launching, map the IAM role which we created. See, step 2 we created IAM role. In part 1, step 2 we created IAM role. I'll map this role here. Okay. That's it. I'll launch. So what I'm doing, so I gave a name app tier instance, gone with Amazon Linux 2023, T2 micro. I didn't give a key. I selected the VPC and subnet. I don't need public access, public IP. I mapped security group. I mapped the IAM role and I launched. Okay. So this instance is ready. This is getting ready. Okay. So I said here, app tier instance in private app subnet AZ1 without public address, and we can map the security group and the IAM role. Okay. Now we will connect to this instance. We will log into this instance via a service called SSM. I haven't taught you SSM, but it is very easy. Maybe if you follow just creating role and mapping to the EC2 instance, connecting to this instance via SSM is easy. Okay, so let me connect to the instance, but we need to wait for a few minutes because the instance is getting ready. We may not be able to immediately connect, so we need to give some time. Okay, so it is initialized. So once this instance is ready, so you can click on connect. See, normally we connect via the EC2 instance connect, but we can't connect today because it doesn't have public IP. So there is a service called SSM. Okay, next to it, there is something called Session Manager, which I might have not used in the regular classes as of now. Okay, and if you just click on connect, it will connect to the EC2 instance. Okay, via the browser itself. Yeah, so now I'm within the Linux instance. Okay, I have connected to the instance. Now, what I'm going to do? So I have launched one EC2 instance and I logged into that instance. Now from that instance, I'll connect to the DB because we know that instances within the VPC can communicate between each other. So we created a DB little earlier. So we can connect to the DB from the EC2 because we can't directly create data via the RDS console. So we can't use SQL commands to insert data within via the RDS console. So that's what we have a EC2 instance. So I'll log into this EC2 instance and I'll create database. I'll create some tables. I'll add some sample values, all that I'm going to do. Okay. Right. Now in part 3, we'll go to configure database section. Okay. First, I'll log in as EC2 user within the Amazon Linux instance. Okay. Login to EC2 instance as EC2 user. See, when you connect via SSM, by default, it will be a regular user called SSM user, but we need to switch to EC2 user. Again, this is Linux activities. Okay, so you are switching as EC2 user. Okay, right. Now, after logging in as EC2 user, if you want, you can check connectivity to Google. You can check whether it has connectivity to internet. The reason why we are doing it is we are going to install some softwares, and those softwares are going to download from internet. Now, how we have internet? Because we already created NAT gateways in the first availability zone and the second availability zone. Okay, so we already have NAT gateways. That's the reason this private subnet instance using the NAT gateway, it is reaching internet. Okay, right. So now I'll install MySQL plugin, which is MariaDB software. So because we have internet connection, it will download the software and it will install in this Linux machine. Okay. Okay, so you can see the MySQL software is installed. Now we can connect to the database. So we created database in part 2. Now we'll connect to that database. If database is created, let's see. Yeah, you can see the database is created. And if you go, there is a DB endpoint. Okay, you will have only one endpoint, even though it is a multi-AZ DB, you will have only one endpoint. Copy that endpoint, and you can use this command. Okay, and you can use the password what you used at the time of creating the database. Okay, and now you are within the DB. So like I said, with the help of SSM, I logged into this EC2 instance, and from this EC2 instance, now I connected to the DB instance. Now in this DB instance, I can use SQL commands. I can create database, create tables, insert values. Okay. Yeah. So for today's application, so the application is programmed in a way to write the data to the database called web app DB. Okay. So I'm going to create a database with the name web app DB. So I'll copy this command and I'll paste it. So this will create a database called web app DB. Now, if you use show databases SQL command, you will be able to see the databases what you have in the database. Okay, you can see there is a database called web app DB just created. Okay, these are some of the default databases. Okay, you can use the command use web app DB to switch to that database. Okay, as of now you are outside, so it says none. But if you use this command, you are changed to that database. Now, if you use show tables, as of now, within this database, there is no tables. Okay, so there is no tables, but you can use this command to create a table. Okay, it says create table if not exist. The table name is transactions. The table is going to have ID, amount, description. Okay, so I'll copy this SQL command and I'll paste it here. This will create a table with the name transactions. Okay, so if you use show tables, this time you can see a table called transactions. Okay, now we can add some sample data into the table. Okay, so I'm going to add a data of amount of 400 and description of groceries. Okay, so I'll use the SQL command insert into transactions. Okay, and this time it added some data, sample data to the database table. Okay, now if I use select star from transactions, this is used to query the data what is added to the table. So now if I use select star from transactions, you can see this is the table, this is the schema we created here, and this is the ID, amount, and groceries. Okay, the value. Okay, right. So now these data is in the database. So we connected to the EC2 instance. From EC2 instance, we connected to database. We created database. We created table. We created some sample data within the database as well. Okay, have you understood? Okay, so this is part 3's second file. Yeah, now I'll log out from the database. Okay, I'll type exit to log out from the database. Okay. Now after database configuration, now we will configure the application. So we will configure application here, the Node.js application here in this instance. Okay. See, I used this instance to connect to the DB and added values, but this server is going to be the application server. Okay. As of now, while launching this server, it was a blank server. I'm now going to configure Node.js application within it. Okay. Now, where is the application? See, I told you at the very beginning of the project, I have all that application code in my local computer. Okay, you can see here, there is a folder called application code in my local computer, and within that I have all the programs. Okay, Node.js related programs. Now, what we need to do is, from my local computer, I can't directly load that file to this private subnet instance, because even today, now as of now, I don't even have public servers. So I can't use jump server and upload data. So that's the reason we created S3 at the step 1. Now from my local computer, okay, from my local laptop, desktop, I have the application code there. I'll make some changes in the code. I'll upload it to S3. Because we have created a role, from S3, we will load the data to the EC2 instance. Okay, this is what we are going to do now. Okay, all right. So I'll do the application configuration. Okay, I'll go to third step. Okay, see, you need to go to the application code in your local computer. You need to make some changes. So you need to edit the JS file, dbconfig.js file in the project directory. Okay. So you need to go to your, I told you I'll share this folder completely later. So when you're practicing, so you need to go to this application code, go to the app tier folder and go to dbconfig.js file. And in this file, you need to add the database endpoint, database username, database password, and database name. Okay. So, yeah. So this is a sample one, which I have given. Okay. So now you need to go to this app tier, and here you need to edit the DB endpoint. Okay. So I'll go to database, get the endpoint. Okay. I'll paste it here. The username is admin, and the password what I used at the time of creating the database is JRS17391. My name and contact number, half of name and contact number. Okay. And the database what I used at the time of creating is that's it. So I think it's look into the previous step.
Web app.
Okay, so the database is web app DB. Okay, so copy this, go to this application code and paste it. Okay, right. See, I know that this application has a configuration called dbconfig.js. This file will connect to the, see, in future, when the application server is running, if a request comes from the front end, okay, it needs to know where to go, which database it has to connect, right? So that's the reason we are adding the database endpoint, username, password, and the database name, okay, in the code, right? Yeah, now I'll save this code. Okay. So once after we edit this part, okay, once after we edit this application code from the local computer, okay, this activity I have done in my local project folder, okay, I edited it. Now I will upload the app tier folder to S3 bucket. So we created S3 bucket in part 1, step 1. Now I'll upload this app tier folder from my local computer to S3. Okay, so from my local computer, I'll upload the data to S3. So I'll go to S3. S3 bucket is empty. I'll click on upload. I'll click on add folder. From my 3-tier project folder, I have a folder called application code. Within that, I have a folder called app tier. Select this folder. This is the folder. Within this only, we made some configuration little earlier. Okay, I'll upload it. Right. So this dbconfig.js and the other JS files, Node.js files got added to the S3 bucket. Okay. Right. So now these data is in app tier folder is in S3 bucket. Okay. Now, once that is done, within the operating system for the backend application, we need to install Node.js. So we are installing a software called NVM, Node Version Manager. So I'll copy these two commands that will download the software and it will install it. Okay, that's the shell script that I'll copy and paste in the Linux command line. Right. So now we have Node Version Manager installed within this operating system. Now I'll install NVM, Node.js application, and I'll ask NVM command to use the Node.js version of 16. I think the latest versions are there, but I just followed the document. Okay, I just copy paste these commands. This will install Node.js version 16. Okay, right. After that, okay, see, there is a daemon process within the Linux operating system called process manager that will keep on checking whether the Node.js application is running or not, even if you log out from the instance or even if you reboot the instance. For that only, we are installing this software called PM2 within the Linux system. Okay, I'll copy this command and I'll paste it. Okay, so this will make sure the Node.js is always running, even if you log out from the Linux command line. Okay. Or even if you reboot the server. Right. Now, see, little earlier, we uploaded the code from local laptop to S3. Now from S3, I'm going to download that data to the server, okay, not to the local system. So it should be to the app tier server, okay. Right. So you need to go to the home directory. Okay, and there use this AWS CLI command. So we know that this is Amazon Linux. Amazon Linux will have CLI command. Because I have created role, it can fetch the data from S3. So from S3, I'm going to download that folder to this EC2 instance. Okay. So I'll copy this command. So 3-tier app EC2 is the bucket name, and where we have already uploaded app tier folder, and that folder is going to get copied to the Linux instance. Okay. Right. Now if you type ls, you'll see the folder app tier. Okay. And if you look into the app tier folder, within that, there is a file called dbconfig.js, where you will have information about to which database it has to connect, which username, which password to be used, and to which database it has to connect. Okay. All these values are there. Okay. This I have edited from my local computer. I uploaded to S3. From S3, I downloaded to EC2 instance. Okay. Right. Now go to that folder app tier. And now we'll start the Node.js application. Okay. So I'll go to app tier folder. Okay, where we have all the JS files. And I'll use the command npm install and this pm2 start index.js. Okay. So this will start the Node.js service. This will start the application within this machine. Okay. Right. So if you use the command pm2 list, this will show whether this application is running or not. Okay. It shows here already saying it is online. Okay. So if you again use the same command, you can verify whether the application is running or not. pm2 list. Okay. Now, if you use a command pm2 startup, even if the server is stopped and started, the service has to start automatically. So if you copy this command and if you paste, okay, it will give a command. Okay, see this, when you run this command, that will give another command, sudo environment path so and so, lnd command. Okay, so you need to copy this and again execute that command in the command line. Okay, so it means when you execute pm2 startup, that will give a command. You need to copy that command and paste it in the command line. Okay, why we are doing it? Because we are, see, if you know Linux, okay, so there is a process called systemd. At the time of starting the Linux system, right, the systemd will start automatically this Node.js application. Okay, for that only we are setting this environment variable. Okay, I'll give this command. So it created some configurations in the backend. Now finally, you can use the command pm2 save. That will save some configurations in the backend. Okay, it says here freeze and process. So maybe we can use pm2 save to save some data in the dump file. Okay, yeah, this is enough. Okay, that's it. So this is how we configure the application within the Linux system. See, these activities are not really done by person who don't know Linux. Okay, so it's again done by people who have experience on Linux and Node.js. Okay, right. So this part is done. Now we can test whether the application is running or not. See, I created only one server. I didn't made highly available. I'll do that little later. So we'll check whether this application is running correctly or not. And also we'll check from this application whether we will be able to reach the database or not. Okay. So now to do that, okay, you can use a command curl http://localhost 4000. I told you the Node.js application will run on 4000. And there is a program called help configured in that application. So if you use curl localhost 4000 help, and if you get a response, this is help check. it means your application is perfectly running. Okay. Yeah. So I'm getting a response. This is health check, which means the application is perfectly running. Now, if I use curl HTTP localhost :4000 and transactions, in the transactions folder, it is programmed in a way. Maybe if you go through all the JSON code, you will understand. Okay. So it is programmed in a way. If you query for transaction, it has to go to connect to the database. Maybe you need to read the programs. Only then you will understand. If you go to transaction, it has to connect to the database. Okay. Right. It will connect to the database. It will fetch the values. It will show. Okay. That's how it is programmed. Again, we don't need to go deep related to program. I'll just copy paste the command. Okay. This will reply with the, I'll use transactions. Okay. So if we use transactions, whatever we have added in the database little earlier, that will show from the EC2 instance. Okay. That's it. Okay. So we have successfully configured one server in the app tier. Okay. But this one server is not really highly available, right? If this server fails, it fails. So we need to have a highly available architecture. Now we are going to do that. Okay. But we have completed till part 3. Okay. So part 3 is done. Now we have 3 more parts to complete. Okay. So yeah. Now I'm going to part 4. Right. So I'll tell you what I'm going to do here. So I'll select this instance and I'll create an image, AMI. We have done long back when we are learning the course. And that image will create a snapshot. Images are backed by snapshot, right? So this is what I'm going to do now. I'm going to select this instance and I'm going to create an image. Okay. Now, once after the image is created, I'll create launch template. Okay, launch template pointing this image. Once after launch template is created, I'll create an auto scaling group setup. Okay, so which means here there are going to be an auto scaling group. This auto scaling group is going to launch instances based on the launch template. But that launch template is from the custom image. So because we configured all the application only in the single server, if you need high availability, you need lot of servers here, right? We can't always keep on configuring the same data. So we create an image, we put it on the template, we connect with auto scaling group. Auto scaling group will automatically launch instance here. Okay, I understood. This is what I'm going to do in this part 4. It will be a little faster, I guess. So creating image, creating a template, and creating auto scaling. Right. So part 4. First step is create image. Right. So create an image with any name of your choice. I'll go with app tier image. So I'll go to action, I'll select image, I'll click on create image. I'll give a name app tier image. You can give any description of your choice. Okay. You don't want to restart the server, just click on create image. That's it. So this will create image and snapshot. Okay, so if you go to AMIs, image is created, image is getting created. And if you go to snapshot, okay, snapshot is getting created. Okay, right. That's it. I'm not going to wait. Let that create in the backend. So I'll move on. Okay, I create a target group. Okay, see, I created image and snapshot. I'm going to create target group, not the launch template. Okay, I'll create a target group. So target group is for the load balancer to forward the traffic to the targets. That's called target group, right? So I'll create a target group. So I'll go to target groups. I'll click on create target group. I'll select instances as the target. As of now, I don't really have the instances, but instances will get created in the future with the help of auto scaling group. Okay. So I'll give the name app tier target group. Okay. And this app tier is listening on port number 4000. I told you the Node.js will run on 4000. So I'll say it is going to receive request on 4000, HTTP 4000. And I'll select the VPC. And there is a folder called help within the Node.js application. Okay, so I'll say the health check should happen to the folder /help. And do the health check only 2 times. Okay, right. So I'll repeat what I'm doing. I don't have instances created with the help of auto scaling group. I just created one instance manually, and I created an image and snapshot. Now I am creating a target group. The target group is going to be empty. Okay. So I said create a target group without any instances. So select the instance, select instances as target. Go with the name app tier target group. The application is going to run on 4000. So select port number as 4000. Select the VPC. Application has a folder path called /help to check the help. And health check timer, I reduced it to 2. And I'll go next. I'm not selecting any instances. Okay, very important. I'm not selecting any instances. I'll click on create target group. Okay, so I created a target group without any EC2 instances. Okay, this is part 4's second step. Now I'll create internal load balance. Okay, so I haven't created the launch template yet. I haven't created the auto scaling group yet. Okay, so I'll create the internal load balancer. Okay, so this is internal load balancer. Okay, so go to load balancers, create a load balancer, create application load balancer. So you can give a name app tier load balancer. Okay. And select internal load balancer. We may have not did it in the regular classes, but yeah, we are going with internal load balancer. Select the VPC and select true availability zone for high availability and place this in the private app subnet AZ1 and AZ2, which means this load balancer is going to be in this subnets. Okay, private app subnet AZ1 and AZ2. Okay, so I'll select private app subnet AZ1 and private app subnet AZ2. Okay, and for the load balancer, we need to map a security group. So we already created a security group called internal load balancer security group. And select that. See, load balancer is going to receive the request on port number 80 only. See, I told you. So from the front end, the request to the load balancer is on port number 80. But the load balancer will forward to the targets on 4000. Okay. Right. Okay, so okay, I'll forward to the target group which we created a little earlier. I'll select app tier target group. And that's it. I'll click on create load balancer. Okay. So I created a load balancer with the name app tier load balancer. I created it in private app subnet AZ1 and AZ2 and selected internal load balancer security group. Okay. Right. Now I'll create launch template. So I go to launch templates. Okay, so launch templates. I'm going to create a launch template. Why we are creating launch template? This launch template is going to be used by auto scaling group to automatically launch instances across availability zone. Okay. Right. So I'll click on create launch template. You can go with any name for the launch template. I'll go with app tier launch template. Okay. So I'll say app tier. I'm creating it for auto scaling group. And image, it's not the image provided by AWS, it's the image created by us. Okay. So we created an image little earlier. Select that image and select the instance as T2 micro, instance type as T2 micro. We don't need key. We can log into the EC2 instance via SSL. We don't need to mention the subnet in the template, that we'll do it in the auto scaling group. Yeah, we need to map the security group. Security group is for this launch template is for creating application tier servers. So map the app tier security group. Okay. So I might have mentioned here, AMI should be app tier image, security group should be app tier security group, and IAM role. So at the time of creating the template, go to advanced details and map the IAM role. Only then, maybe if you want to load data from S3 to the EC2 instance, or if you want SSM to access the EC2 instances which you are going to launch in the future, you can use, you can do that. Okay, so that's what I'm mapping, and I'll click on create launch template. So launch template is done. Okay, now I'll create the security auto scaling group. Okay, so I'll create the auto scaling group in the app tier. So this is going to launch EC2 instances automatically in first availability zone and second availability zone from the image which we created. Okay, because the launch template is pointed to the image. So auto scaling group will use the launch template and it will launch EC2 instances automatically. Okay, so let's do that. So I go to auto scaling group. So I'll click on create auto scaling group. You can give any name of your choice. I'll go with app tier auto scaling. Obviously, this is app tier's auto scaling. Right. So I'll select the app tier launch template. Okay, and I'll select the VPC. In the template, we haven't selected the subnet, but here we can select the subnet. So here we need to select the subnets, private app subnet AZ1 and private app subnet AZ2. So I'll select private app subnet AZ1 and private app subnet AZ2 because the EC2 instances are going to be placed on the private app subnet. Okay, right, I'll go next. And at the time of creating the auto scaling, because we already have a load balancer, internal load balancer. So the internal load balancer is going to forward the traffic to the instances which are going to get created in the future. So I'll select attach an existing load balancer and I'll select the target group which we have created already. See, when we created a target group without any instances, because we don't have instances at the moment, but when auto scaling group is launching instance, that those instances will get placed in that target group. Okay, so I'll select that target group and I'll enable load balancer health check. That is very important. So load balancer will check whether the servers are running. Only then if this server is failing or if this availability zone is failing, it will forward traffic to the other availabilities. Okay, I'll change the health check timer to 150 seconds. I'll go next. Okay, I'll go with 2 servers as the desired capacity. And I say I want minimum 2 and I want maximum. I am not really going to scale the servers. I'll have 2 servers in total of 3 servers. Okay, right. I don't need any scaling policy. I'll go next. I don't need notification. I'll go next. I'll go next and I'll create. Okay, this will create 2 EC2 instances from the launch template. That launch template is pointed to the custom image and that image is created from the instance which we launched and where we configured a lot of application, where we have used a lot of Linux commands to configure the Node.js application, which means these 2 instances are also going to be Node.js application running on 4000. Okay, right. Okay, so I'll click on create auto scaling group. So now at this point, if you go to EC2 instances, okay, you will have two more instances getting created. You will see two more EC2 instances getting created. Okay, you can see here two instances are getting launched, one in 1A and another in 1B. Now, if you want, you can even select this instance and terminate, okay? Because we created this instance to do the manual application configuration. From there, we created image. Then we used auto scaling group. So auto scaling group can now use the image to automatically scale the application tier, okay? Right. Okay, so now these EC2 instances might have also connected to this database, okay? Because the db-config.js files will be within this EC2 instance, so it can connect to the database. Okay, right. So maybe if you want, you can name it as app1, and this is app2. Okay, so app1 is in 1A availability zone, and app2 is in 1B availability zone. Right. Okay, so we'll move on. Finally, so we'll do the web tier configuration. Okay, so we have two more steps. I think I'll be able to complete it in another half an hour. But let's see. Okay, so in part 5, what I'm going to do is, okay, so now we have actually created two tiers. Okay, so this DB tier is done. This app tier is also done. Okay, now finally we need to create the web tier. Okay, that is part 5 and 6. Okay. So I go to part 5. Right. See, this EC2 instance is going to be running Nginx web server. Okay. So normally in our classes, I might have used Apache a lot, but here there is Nginx. Nginx is also a web server software. Okay, like Apache, like Internet Information Service. Okay. Now, in our local project folder, this is the project folder. In that project folder, we have a Nginx configuration file. Okay, you can see here, right? This is my project folder. I'll share that to you. In that, there is a Nginx configuration. Okay, so maybe Linux admins will know about Nginx if they have used Nginx, if they have worked on Nginx. Okay, this is a Nginx configuration file. Okay, now in this Nginx configuration file, go to line number 58. Okay, there is a line called proxy pass. Okay, here you need to replace the endpoint, this portion, with the load balancers endpoint. The reason is, see, I'm going to configure Nginx server, and that Nginx server is going to forward traffic to this load balancer, right? So Nginx should know where to connect. That's what we are editing that configuration file, nginx.conf. Okay. As of now, I don't have instance. Okay. So I'll go to my local computer. I'll change this. I'll remove this, and I'll get the load balancers endpoint. Okay. So I go to load balancers. So this is the internal load balancer. Copy the DNS name of internal load balancer and paste it here. Okay. Right. So, and save this in your local computer. Okay. So this nginx.configuration file now knows that to which load balancer it has to connect. Okay. That is part 5's first step. Now we need to upload that Nginx configuration file and the web tier folder. See, in part 3 or 4, we actually uploaded application tier folder to S3. Now we are uploading Nginx configuration file and web tier folder to S3. Okay, so I go to S3 again. Okay, I'll click on upload. I'll click on add files. Okay, I'll go to 3-tier project in my local computer. I'll open this nginx.conf file, as well as I'll add a folder. I'll add the web tier folders. Okay, this will upload all the Nginx configuration file and the website React.js website related code to S3. Okay. So this is part 5 first. Okay. Now I'm going to launch instance. Okay. So I launch one instance like I did for app tier. I launch one instance manually. I'll do manual configuration on one instance. Okay. I launch one instance. I'll name it as web tier instance. Okay, I'll log into it and I'll configure Nginx website. Okay. Yeah. So I'll go to EC2. So I'll click on launch instance. I'll say web tier instance. Okay, so web tier instance. I'll go with again Amazon Linux. Okay, I'll go with T2 micro capacity. We don't need keys because again we are going to log in via SSM. Okay, and I'll select the 3-tier VPC of C, a small change. Because we are going to install softwares, I'll place this instance here itself. Okay. Obviously, the web tier instance needs to be in the web tier, but manually created instance, I'll place it here. Okay. The reason is, I'll tell you the reason. As of now, I'll create the web tier instance here. Okay. That's how I documented it. Okay. I said launch EC2 instance, web tier instance in the private app subnet. Obviously, it has to be in the public web tier subnet. But as of now, for the manual creation server, this is a manually created server, right? Manually created server, I'll place it here. Okay. I'll tell you the reason little later. Okay. So I'll select private app subnet AZ1. I don't need public IP. Okay. And I'll map the security group, web tier security group. Okay. So I'm placing it in the private subnet without public IP, but I'm mapping web tier security group, and I need a role for the instance. Okay, the role which I created. Now, why I am placing it here? See, this is not going to receive any traffic from the load balancer. This is a server which we are creating manually. That's the reason I am placing it in the private subnet, and I want SSM to connect to this instance. I don't want people from internet to log in. So that's the reason we are placing this instance in the private subnet. Okay. But from this instance, I'll again create image. I'll again create launch template. I'll again create auto scaling group. While doing those things, I'll place the front end servers in the public subnet. Okay. Right.
Can you repeat the reason once again?
Okay. So that's it. Okay. So I'll go with the name web tier instance, Amazon Linux C2 micro without key, private app subnet AZ1, web tier security group, and the role, and I'll launch. Okay, so this will take some time for the instance to get created. We'll wait. Okay, once it is created, we will log into the instance, and then we'll check whether this instance has internet connectivity. We can check whether Node.js, the Nginx website is running or not. Okay, so web tier instance is getting ready. This server, okay, web tier instance is getting ready. So where we are, We are in part 502. Second step. Okay. Once it is ready, I'll log into the instance and I'll check whether it has connectivity to internet. The reason why we are checking connectivity to internet is we are going to configure Nginx applications manually. Okay, so let's wait. Let's check. Okay, so I'll try to connect to it. Okay, so session manager is ready. So I'll log into the instance. Okay, I'll log into the EC2 instance. I'll switch as EC2 user. Okay, so I'll switch as EC2 user. And from here, I'll try connectivity to internet. It will be there. Okay, and now we'll do part 5's third step. Okay, we will install necessary component for the front end application. So little earlier in part 3 and 4, we were doing the app tier configuration. Now we are going to do the web tier configuration. Okay, so I'll use curl to download the Node version manager and install it. Okay, so I will copy paste all these commands. Then I'll go to the folder home directory, and this time I'll be configuring web tier folder. I'll be downloading the web tier folder from the S3 bucket. Okay, so this web tier folder also has, this web tier folder has the website related configuration. Okay, right. So I'll go to home directory and I'll copy all the data. Okay, now if you use ls command, you can see a folder called web tier. Okay, right. Now go to web tier folder, install npm and build that application. Okay, so here navigate to the web tier folder, create a build folder for the React application. See, we have a lot of code. That code has to be built. Okay, right. So I'll go to that folder and I'll build. Okay, it will take time. You can wait and check. Once it is done, now we'll install Nginx. Okay, we'll wait and check. Okay, it will take time. Some warnings, deprecation warnings are there, but we can ignore it. Okay, do not. Okay, so now I have built the application. Now I'll install Nginx. Okay, I'll copy this and I'll paste it here. This will install Nginx web application software within this Linux instance. Okay. Okay, so now we need to go to the folder /etc Nginx. See, if you are a Linux admin, when you install a software within the etc folder, there will be configuration files. Okay, there is a configuration file called nginx.conf. Okay, but I don't need that file. I'll delete it. Okay, the reason why we are deleting it is we will remove the default configuration file and we will upload the configuration file what we have already uploaded to S3 from S3. See, in S3 we uploaded a file called nginx.conf little earlier. So here it is. So this file has configuration pointed to the load balancer. So we will copy this file to the Linux instance. Okay. So that's the reason I'm removing the default Nginx configuration file. Now from S3, I'll copy the nginx.conf to the current folder. Okay, I'll copy this command and I'll paste it. Okay, now if you look into the Nginx configuration file, in line number 58, the proxy path will be pointed to the load balancers endpoint. Okay, right. So that's it. Now we will restart Nginx service using this command. Because we have made some configuration changes, Linux admin knows that if something is changed within the OS, it has to be restarted. Okay. So I restarted the service. I'll change the permission for the home directory for some files to be read by the application. I'll change permission and finally I'll enable the service. This will start Nginx even if the server is restarted. Okay. Right, done. So we have done part 1. Finally, right. So finally, what I'm going to do is, see, I created this instance and I logged into this instance and I made that instance as an Nginx web server pointed to the load balance. Now what I'll do is, I'll create an image. And that image will create a snapshot. And like we did for the app tier, even for the web tier, I'll create an auto scaling group. I'll create a launch template and auto scaling group. Okay, that is what I'm going to do. Okay, so that's our last part. Okay, I go to part 6. First, we'll create the image. So this is the instance where I configured Nginx web server manually, but I want a copy of this instance that has to be used by auto scaling group to automatically launch instance in different availability zones. Okay, so I'll select this instance, I'll go to action, I'll go to image, create image, and I'll say web tier image. You can give any name for the description. You don't want to restart the server, click on create image. Okay, this will create an image and a snapshot. Okay, so this will create an image and a snapshot. Okay, part 6 first step is done. Now we'll create a target group. See, while creating app tier target group, I was saying it has to listen on port number 4000, but now I'm creating a target group for the web tier. Web tier is going to receive request on port number 8. Okay, right. So I'll create a target group. Again, while creating target group, I don't need to create any instances because auto scaling group will launch instances in the future. So okay, I'll go to target groups. Okay, I'll click on create target group, instances as target. This target group is for web tier and web tier will listen on port number 80. Okay, I'll map the VPC and health check. There is again in Nginx as well, there is a help folder called /help and do the check for 2 times. Okay, go next. and I'm not mapping any instances, okay? Because I want instances to be automatically placed by auto scaling group. So I'm not selecting any instances. I'll click on create target group. Okay, I created a target group, right? Now I'll create load balancer. This is internet facing load balancer. Create an internet facing load balancer. So we are going to create the external load balancer or internet facing load balancer. External LB, right? Okay, so I'll create a load balancer with the name web tier LB. You can go with any name. So I'll go to load balancer. We have one load balancer. This is for internal load balancer. This is for internal. Now I'm creating another load balancer. This is an external load balancer. Okay, web tier LB. I'll say internet facing. I'll select the VPC. I'll select two subnets, and this subnets should be public subnets. Okay, because this is a internet facing load balancer. So I'll put this load balancer in the public subnet, and I'll map a security group for this load balancer, which is internet facing load balancer security group. Okay, and the traffic to this load balancer will be on port number 80, and that will forward the traffic to the target group web tier instances, web tier target group. As of now, this web tier target group doesn't have any instances. Instances will be launched by auto scaling group in the future. Okay, right? I'll click on create load balancer. Okay, so load balancer is created. This is internet facing load balancer. It is getting created. Okay, right. Now create a launch template. Okay, so create a launch template and create a auto scaling group. Auto scaling group will use the image and automatically launch instances. Okay, that is what it is going to happen. Okay, right. So I'll go to launch template. So I'll click on create launch template. So this launch template is for web tier. Okay, you can give any name. I'll say web tier, and we are going to use this template for auto scaling. And we created another image, right? So from this instance, we created an image. So now I'm using the Nginx image within the launch template. If I use it in the auto scaling group will automatically launch Nginx web servers in a scaled way. Okay, right. So I'll select the web tier image. I'll select so I'm selecting T2 micro capacity. Like I don't need key. I want the instances to be placed in the while creating the template, we don't need the subnet. We will do it in the auto scaling group section. And I'll map the security group in the template. I'll say web tier security group. And I want the role to be mapped. Okay, so I might have mentioned here. So create a template with the name web tier template. Select the web tier image, web tier security group, and the role. Right. That's it. So I'll click on create template. So now finally, the last step of the day. Right. So I'll create an auto scaling group. Okay. So I go to auto scaling group. See, we already have one auto scaling group. This auto scaling group is for the app tier. Okay. Intermediate layer, we had auto scaling group. Now I'm creating one more auto scaling group. This is for the web tier. Okay. So I'll click on create auto scaling group. I'll name it as web tier auto scaling group. I'll select the web tier launch template. Web tier launch template will have Nginx image. I'll go next. I'll select the VPC. I'll select the availability zone. So this time I'll select public subnet AZ1 and public subnet AZ2. See, while creating this instance, I created it in the private subnet, but now from the image, from the launch template, when auto scaling group is launching instances, those instances needs to be in the public subnet. Okay. Right. Even though I am placing it in the public subnet, I don't need public IP address. Interesting. The reason is people are not directly going to access the EC2 instance. People are going to access the load balancer. Load balancer is the one going to forward the traffic to the EC2 instance, right? So we don't want to waste public addresses in a production environment. So even if you are working in a company, so even if you have public subnets, you don't need public IP because load balancer can forward traffic to the targets. Okay. Right. So go next. Attach a load balancer. See, we created already a load balancer and the target group. The target group doesn't have any instances. Now I'm saying that the instances has to be placed in this target group. Okay. And I'll enable health check. And I'll say 150 seconds is the grace period. I'll go next. Again, in the front end, I want 2 instances. Okay. For high availability. And I'll say minimum is 2, maximum is 2. I don't need any scaling, but all this will be done in a production environment. I'm not doing it. Okay. So I'll go next. I don't need notification. I go next, and I'll click on create auto scaling. Okay. So this will create EC2 instances in the front end. So now we have in total of 8 instances. 2 instances in the public subnet, 4 instances in the private app subnet. But within the auto scaling group, you have only 2. 2 we created manually, and we have 2 DB instances. Okay, have you understood? So you have completed the project. Okay, but I know it's very hard. See, I want you to try at least 2 times or 3 times. Maybe when you try 2 or 3 times, okay, so you'll be able to understand a lot of things. Okay, right. Okay, now if I go to instances EC2, here it is. Auto scaling group will automatically launch 2 instances. Okay, so you can see 2 instances are launching. Okay, I can name this as Web1, and I can name this as Web2. Okay, right. Okay, so we have completed the project. So now how can we access it? What is the output? See, for this load balancer, there will be a DNS name, public. This is an internet facing load balancer, right? So that load balancer name can be changed with Route 53 if you want. With the help of Route 53, you can change it if you want. Okay. So people in Android, when they send query to Route 53, Route 53 will serve the DNS name of load balancer, and traffic will go to load balancer, which will listen on port number 80. That will forward to the target group, okay, which is on port number 80. That will serve the website. Okay, these instances will serve the website to the internet users. Okay, and website is very simple. Okay, so if you look into the website, okay, let's see. So if I go to load balancer, this is web tier load balancer, which is an internet facing load balancer. Okay, I'll copy the public DNS name of the load balancer, and if I try accessing it, I hope we'll get the website. Just changed the health check timer from 150 to 150 to 300. Okay. Then after that, I was able to access the load balancers endpoint, and via the load balancers endpoint, I am able to see the web page, the React application, and When I go to DB demo, by default, it was showing only the groceries, 400 groceries, this data. I added 1500 and laptop and I clicked on add. So what happened? So the data goes to the Elastic load balancer and it forwards to this front-end servers. Those front-end servers are connected to load balancer, internal load balancer, and internal load balancer is going to the application tier, and application tier writes the data here. I told you the application tier will normally do the business logic based on some orders. So if somebody is doing order, right, based on the order, if the product is available, maybe it will get integrated to some other Lambda function. So if it is there, then it will write to the database, or it may be not writing to the database. But my application, the sample application, what I used from Amazon is not really doing a lot of things. It is just directly adding that value to the database. Okay. I haven't added any Lambda integrations or anything, but I just created this highly available application. Okay. See, like I told you, right? This steps, what I have documented is perfect. Right. When you do the load balancer target group or the lost and auto scaling group, that do the health check as or increase the health check timer as 300. Other than that, okay, everything is good. Okay, it will work. So what I'll do is I'll do a cleanup. So go to the database part directly. Okay, delete this database, multi-AZ DB. Okay, I don't need the database. Okay, so I'll go to database. I'll select the database and I'll delete the database. Okay, at the time of deleting, you don't need any final snapshot. Uncheck this. You don't need to retain any backups. Acknowledge and say delete. This will delete both databases. Okay, this database, it is a single line, but it actually has two databases because it's multi-AZ setup. There will be two databases in the backend. We can't see that, but that's how it will be. So now I have deleted both the databases. So this is first cleanup. I deleted both databases. Okay, then, okay, I'll delete this auto scaling group, application layer auto scaling group. So go to auto scaling groups. See, we have two auto scaling groups. Okay, so one is application tier auto scaling group and another is web tier auto scaling. We can delete both at one go. Okay, see, deleting the auto scaling group will automatically delete the instances within the auto scaling group. So which means these 4 instances will get deleted. So you can select both the auto scaling group and you can go to action and delete it. Okay. So like I told you, both auto scaling groups are deleted. Instances will also get deleted, but it will take time. It will take a lot of time to get deleted. Okay. So it says it's in the state of deleted. Okay. Now I'll delete this load balancer and this load balancer. Okay. 2 load balancers. Okay. So I go to load balancers section. We can select both the load balancers and delete this load balancer. Okay. So I have deleted both the load balancers. Now there is 2 target groups. I'll delete it. So target group is not going to cost you, but I don't need. I'll delete it. So auto scaling group is deleted. Load balancer is deleted. I go to images. See, we have created 2 images. So I'll delete both the images. So deleting the image, you need to also delete the snapshot related to it. Okay. So go to image, select both the images and deregister it. At the time of deregistering, you can delete the associated snapshot. Okay, so the image and the snapshot is deleted. So you don't have images, you don't have snapshots. Elastic IP is there, security group is there. Okay. Now go to launch template. Select the launch template and delete it. Okay, so 2 launch templates are deleted. So even though we deleted the auto scaling group, there will be servers running. It will take a lot of time to delete. But if we don't want to wait, so what we can do is we can select all the servers which are running and we can delete it. Okay. Right. So this will delete the manually created instances as well. Okay. It will delete the servers from the auto scaling group and the manually created instances. Okay. Right. Now, database is deleted. EC2 instances, launch template, image, snapshot, load balancer, auto scaling group, all is deleted. Now we need to go to VPC finally. So go to VPC, we have 2 NAT gateways. NAT gateway is costly. So select NAT gateway, delete it. Select the second NAT gateway, delete it. You need to wait. So you need to wait for the NAT gateway to get deleted and then release the elastic IP. Okay, elastic IPs will be there. So you need to release it. Okay. You need to wait for some time. Okay. Yeah, actually, we can place that instance in the public subnet, but I didn't go with public IP. Okay. So that's the reason I launched it in the private subnet and then created image. But after creating the image, auto scaling group created the front end in the public subnet only. Okay. AMI, after creating the image created EC2 instance within the auto scaling group in the public subnet. We can create anywhere. Okay. That doesn't matter. Okay. But why I created in the private? Because I didn't give a public IP. I want to save one public IP. So I put it on the private subnet. I understood, because I can't connect, right? I don't want to connect from internet. I want to connect via the SSM service. That's the reason I put it on the private subnet. Okay. Okay. So now let's check whether we can release this. Yeah, now we can release the elastic IP. So both the elastic IPs are released. See, go to VPC, select the VPC, delete the VPC. Okay. The VPC itself is not needed. So if you can able to delete the VPC, it means there is no resources within the VPC. We created almost everything within the VPC, right? If you delete the VPC, all the security groups, subnets, everything will get deleted. But you can't delete when the instances are running. That's what I deleted the instances, load balancers manually, then deleted the VPC. Okay. Now, for sure, no resources are there. Okay. No VPC, no subnets, no routable, no internet gateway. Okay. No elastic IP. That gateway is getting deleted. It will appear here for a few minutes. No security groups. All security groups will be deleted. Okay, that's it. Now we have S3 bucket in AWS Cloud and IAM role. Okay. So that's not going to cost you. But if you don't want the role, you can delete the role. And you can delete the bucket. Okay. Empty the bucket. And delete the bucket.